All right, so I'll get started. Hi, everyone. I'm very excited to be here at the symposium. I'm Ana-Andreea Stoica, and I'm a PhD student at Columbia University in the computer science department. And I'll quickly chat today about a recent project called Seeding Network Influence in Biased Networks and the Benefits of Diversity. And this is a project I've been doing with my collaborators, Jessie Shinihan, and my advisor, Augustine Chantro. And if you're at the web conference today, I'm actually presenting this there today too. And this is a short version of that. So to get started, the social influence problem basically tackles the way information gets propagated through a network. And that has many applications, from the way that we read the news, from the different technologies or opportunities that we hear about, probably the most important one being in public health issues, but also in other campaigns like marketing promotions, how do things become viral, how to do advertisement, and so on. And there are many different important applications, especially in public health issues, from modeling the way that a disease spreads. And I know a lot of people are working on the spread of COVID-19, but also in how do you actually target people to inform a population well in terms of guidelines or healthcare issues and things like that. And there's been studies working on this problem on how, for example, how do microfinancing loans can distribute in a population. This is a study being done in rural areas of India, and how do people talk to each other about it. So how does information spread in an offline network? There's also been a lot of issues regarding who gets this information. So who gets this access to opportunities? And Facebook and other platforms have been under scrutiny because a lot of advertisement companies have been shown to be quite biased. And in the end of the day, what matters is really who gets this information, because this access to information through a information campaign can be an access to opportunity. But even more important than that, as we see in public health issues, it can also be an access to safety. So this is the problem that we're tackling in this project. How do you design information campaigns in a way that's actually fair? And the main problem in more formal terms is that, let's say you have a population and people come from different communities, whether this is demographics or interests or things like that. And imagine that the problem setup is you have to maximize outreach. You have to maximize the number of people who receive this information, which is like very important in case like public health campaigns. So what you're going to do is you're going to pick a set of early adopters, so-called, the first people who receive this information, and they're going to spread it to their friends, who are going to spread it to their friends, and this process kind of cascades. And the question is, if you're trying to maximize the number of people who get this information in the end, how do you pick these early adopters? If you pick people who are more central, perhaps you will have a better chance. However, because a lot of networks are quite unequal, a lot of these algorithms that are trying to make these choices pick people in a biased way. So imagine you have an algorithm that picks from a majority group. In this case, let's say you have people of a blue label and red label. And this can mean, again, demographics. It can also mean different affiliations, like political interests and things like that. And if it picks mostly blue people in the early adopter set, then it may happen that in the end of the day, people from minorities don't have the same access to that information. They're just left out of the loop. And there's been recent works that show that this bias in social structure can lead to bias in outcomes. And especially algorithms that ignore demographics or ignore labels are particularly prone to reinforcing bias. So some of these diversity interventions are often posed as like a parity constraint in optimizing a function to maximize the outreach. And by a parity constraint is that, I mean that they're trying to ensure that the population who receives the information is mirroring the population at large. So if you have like 30% from a minority group of people in a population, you're trying to aim that 30% of people who get information are from that minority group. And a lot of those works that assume full network information are based on greedy algorithms, and they show that there is a fairness efficiency trade-off. So the more equitable you're trying to be in who receives this information, the more you're going to lose in the number of people who actually receive it. And here in this project, we take a different approach. And we acknowledge, in reality, networks are actually partially known. So we focus on other measures of centrality, like the number of your connections and things like that. And we're trying to, oops, I have a typo there. But, oops, sorry. Okay, I have 30 more seconds. But the main idea that I want to share with you is that we can actually, by being more aware of the network structure, we can actually increase equity and increasing efficiency at the same time. And the main idea behind this is that if you're trying to increase equity in your outreach, you can actually be more equitable in your early adopters and tap it actually into inactivated communities that are less central. And because they're less central, they have never seen that information. So intuitively, they're actually going to be more part of the loop, and you're going to be more efficient with the way you maximize outreach as well. And the vision is just that bias is a sign of inefficiency in the end. So I'm going to stop here as I'm out of time. But the main idea is that we're able to show that you can be more fair and more efficient if you're just aware of the network structure. And we're able to show that with a theoretical model that reproduces unequal networks and on real data. So thank you so much. This is my email and my Twitter. If you have questions, I'm happy to take them.